Hey everybody, I want to talk about the unit circle today. And the place where the unit circle starts is with a triangle, actually, two triangles. So let me just get a little triangle here. The first triangle is the 30, 60, 90 triangle. And the way I remember this triangle is that I remember the numbers 1, 2, and the square root of 3. That's the three sides of this triangle. Now, since we've done the law of sines, we actually have a way without doing any math to assign 1, 2, and the square root of 3 to these three sides in order, because from smallest to biggest, we know that the law of sines tells us that there's a connection between the size of the angle and the size of the side. So the longest side goes with the longest angle, the biggest angle, and the shortest side goes with the shortest angle, and the middle side goes with that middle angle. So that's going to be the way that that's organized. So I'm going to put 60 up here. I'm going to put 30 down here, and then I'm going to put these sides in. 30 across from 1, 60 is across from the square root of 3, and 90 is across from 2. So from here, I can build, knowing SOHCAHTOA, I can build 4 statements, well, more, but the ones that I'm interested in are sine and cosine. Okay, so if you just take a minute, give me the opposite over adjacent, opposite over hypotenuse, and the adjacent over hypotenuse, and let's fill out what sine 30, cosine 30, sine 60, cosine 60 is. Okay, so I give you a minute to do that. Sine of 30 is a half, cosine of 30 is the square root of 3 over 2, sine of 60 is the square root of 3 over 2, and the cosine of 60 is 1 over 2. Okay, so that's half of the information that I need for the unit circle. The other half comes from the isosceles triangle, the 45, 45, 90. And so this triangle is just going to be, again, it doesn't really matter in terms of, having this be a perfect drawing, but I do try to make it look decent. So with this one, I just start with the fact that these two sides have to be equal. I use the number 1 just to make it easy for me. So then I can use the Pythagorean theorem to finish this. 1 squared plus 1 squared equals c squared. So it turns out this is the square root of 2. So from here, I could do both corners again, but it's the same because it's the same angle. So cosine 45 and sine 45. So this is 1 over the square root of 2, and this is also 1 over the square root of 2. Often rationalized to be the square root of 2 over 2, which is, I don't really care which way you represent it. At this point, we're ready to build the first quadrant of the unit circle. Okay, so I've used the words unit circle a bunch of times. Let me just explain the theory of what the unit circle is and what it does. Okay, so unit circle is a circle centered on the origin 0, 0. And it's a tool for us to link specific values of sine and cosine with exact ratios, sometimes just whole numbers, integers, that are located in the 360 degrees. We can obviously extend that beyond based on what we've talked about in terms of angles. So for instance, because of the unit circle, you can say to me, Ben, I want to know what the sine of 330 degrees is, and I can come up with that number based on this structured framework. Obviously, I haven't memorized what the sine of 330 degrees is. I have a way of getting there. So the first step is to know what the first quadrant looks like. And so what I'm going to do is I'm going to erase everything except for these values. And I'm going to redraw the first quadrant here. Now, remember when we talked about quadrants the first quadrant is just this top right corner here. And we're going to have 5 points to kind of start with. That's technically only 3 of them are in the first quadrant, and the other 2 are the place where the circle intersects the x-axis and the place where it intersects the y-axis. I regard those as easy points. This is 1, 0, and this is 0, 1, although it is very common and easy to get those numbers mixed up. So you got to really think about, okay, x, y coordinates, and who's 1 and who's 0. Okay, but from there, I'm going to put in coordinates for these. Let me back up a second. The reason I know this is 1, 0 and this is 0, 1 is because it's a unit circle. A unit circle has a radius equal to 1. And if the origin is here, then 1 unit away from 0, 0 puts me at 1, 0, and 1 unit away from 0, 0 in the y direction puts me at 0, 1. So this is the point of having it be a unit circle. All right, so from here, then I'm looking at the value of x and the value of y. And this is an important understanding moment. So let's not just blow past this. I'm going to go ahead and draw the triangle that I would make if I linked up this point, which is on the unit circle, the origin, and the point directly below that point on the x-axis. Okay. So I'm going to go ahead and redraw that with a different color. This is here, here, and here. Now this angle is 30 degrees. This is the first important marker on our unit circle. And from there, I can just use basic trigonometry again to link up the x value and the y value, because the x value is going to be the cosine of 30. Think about the sides involved here. I don't know what x is. I can say that cosine of 30 is the square root of 3 over 2 based on our 30, 60, 90 triangle. And this side is 1. Remember, this side is 1 because that's the radius of the circle. So now I've got a statement that says cosine 30 equals x over 1. Okay, well, that's just x equals cosine 30, which is just saying that x is the square root of 3 over 2. Same thing for y. The sine of 30 is going to be y, that's 1/2. And so it goes all the way around the circle. The cosine is the x value. So this is the square root of 2 over 2. And this is also the square root of 2 over 2 because they're both 45 degrees. For cosine of 45, sine 45, both the same value. And then I do 60, and 60 is just the same as 30, but the coordinates are reversed. Now, once you've built the first quadrant, all of the other quadrants can be constructed through reflection. What do I mean by that? Well, let me get rid of this. And I'll just do the second quadrant, and then you can kind of work out the rest for yourself. So here I am in the first quadrant. Use a different color. I'm sorry for my drawing, but it is what it is. I'm going to draw arcs and parts of the circle. Okay, no, that's not great. But so for instance, let's just take the 30-degree one. We know that that's the square root of 3 over 2 and 1/2. And we know this is 30 degrees. There's going to be another one on the other side here. This is 30 degrees. Now, just by symmetry, we know that the y value is the same height, right? We just flipped it across. And all that's changed is that the x value is now not positive, it's negative. Okay. Now, 30 degrees is not the name of the angle we would give this because it's 30 degrees short of 180 degrees, which means that it's really 150 degrees. The other thing to keep in mind, so all of these can just be flipped, right? Negative square root of 2 over 2, square root of 2 over 2, and negative 1/2, and the square root of 3 over 2. So all of those points are just these guys flipped over, but now the x is negative. So the same thing happens as we go down, then the x value stays the same, but the y value turns negative, and then you can get the fourth quadrant from either going this way or this way. Kind of up to you the way you want to think about it. Now, I can't stress how important the unit circle is in terms of your mental knowledge and the map of these key values that you're going to be thinking about. So the kinds of questions that you're going to face, like I said, the sine of 330 degrees, but also you have to think in terms of pi, radians, right? What is the cosine of 7 pi 6? These are the things you're going to be able to do with no calculator. This is a critical thing. And I can say this and I can test you on it. But in the practicing of it, right, you can kind of cheat or not pay attention to the fact that you need to be able to do this with a calculator, because you can just type it into your calculator. Of course, if it comes out as the square root of 2 over 2 or the square root of 3 over 2, you have to kind of recognize what those decimals are, or have a good enough calculator that it actually gives you the answer exactly. But the point is, you need to be able to do this without the calculator, because it's building a mental map that is going to be very important in terms of your understanding of everything that follows in terms of the functionality of sine and cosine, and also all of the other functions. So this is something that you don't want to just breeze past. What I recommend, and I've built this into the homework, is that you build the first quadrant from memory and you build the whole unit circle. I can't remember what the assignment is, if it's building the first quadrant, building the whole unit circle. But again, you really want to push yourself to do that. Get a blank piece of paper, start with the 30, 60, 90 triangle, start with the 45, 45, 90 triangle, and then build that first quadrant. From the first quadrant, use reflection to build the second, third, and the fourth quadrant. And do that until it feels comfortable. It's like there's no shortage of a number of times that you can do that until you become fluent in it, right? At the point where you become fluent in it, then it doesn't matter anymore and you don't have to continue practicing it. But it's the kind of thing that you would want to practice a bunch and then kind of intermittently throw in a little unit circle practice. So you wake up on a Sunday morning, like, let me see if I can build that unit circle from scratch. So, again, all a teacher can do is say words and hope that people will pay attention to their advice. But this is so critical in terms of your understanding of trigonometry and your success and calculus and going forward. All right, I'll talk to you later.